Greetings, coders. Let's check out the isPrime problem, and let's try to think of an algorithm here. In other words, a cooking recipe, basically, right? You add your baking soda, you add your baking powder, etc., etc. Steps 1, 2, 3, 4. That kind of approach. Let's check out this. Let's figure this one out. This could get long, so I'm gonna go kind of speedily to try to keep it somewhat short. What is a prime number, first of all? Well, prime number is, let's check out the numbers 1, 2, 6, 8, 9, 11, 12, for example. Can we divide 1 up into other numbers? Nope. 2? Nope. 6, yes. 2 by 3 times 3. 8, yes. 2 by 4. 9, yes. 3 by 3. 11, nope. And 12, yes, 2 by 6, and 3 by 4. All right, so anytime we find a factor, that means we can divide, in other words, chop that number up, divide it into smaller pieces. It is not prime. Our cases we're looking for, the prime cases, are these cases here, where we cannot divide a number up into smaller components. How do we do that from an algorithm perspective? Well, we actually want to just check the numbers that are smaller to see if they can divide that number, right? And we'll call that number n. We could call it num, whatever, but we'll just call it n for our case. So we want to do a loop, right? We want to loop from, where do we start? We want to loop from, we don't care that, let's say 11 divided by 1 equals 11. That doesn't help us. I mean, that's not a factor. So we don't care about 1, so we want to start at 2. Loop from 2 to where? Again, we don't need to divide 11 by 11. That just tells us that it's divisible by itself, which we know. And that's not a different factor. So 2 to n minus 1. All right. So for this case here, we just need to loop up to 10 and check all those out. And that could be optimized, but we'll go with n minus 1 here. And we'll call it a loop variable x. All right. Then during the loop, if that number n is divisible by x, we can return false, right? So in other words, for number 6, we're going to loop through the values 2 through 5, but right away in the first loop, we're going to find that 2 divides 6. Well, let's return false. Let's check out 9. We're going to first check out 2 as a factor. Is 9 divided by 2, is it divisible by 2? No, it's not. Let's go to the next one. 3. Is 9 divisible by 3? It is, so we return false and we're done looping. What happens to 11? We check out 2, 3, 4, all the way to 10, and is 11 divisible by any of those numbers? It is not. This is never true, so we never do this. So we get to the end of the loop. Past the loop, we could say. And in that case, we return true. Like we checked out for 11, we then have a prime number. That's groovy. This is something that's very helpful in algorithms and coding, special cases to handle those. And on top of the function is a nice place to do it. And you can look this one up, do a little research on this, but if mathematicians say that if n equals 1, turn false. But 1 is not prime. Mathematicians say if n equals 1, it is not prime. Well, we know that 2 cannot be divided up also, so let's return, in that case, we return, not also, but I should say 2 cannot be divided up. We return true. We have a prime there. One special case. I should change that. That's a special case, and you can do some research on why the mathematicians call that false there, non-prime. We have another one. If n is even, what do we have? So we're beyond the 2. We already have returned a true there. So if n is even for all other numbers, 4, 6, 8, 10, they're all going to be divisible by 2, right? So we would return false. So we've handled a few special cases there. We can now change our loop here, and you can think about this a little bit too. We would need to start only from, we can bump that up to 3. We don't need to even check out 2 because we're doing that here. We would check out 3, but we can also loop by 2 each time. In other words, we can increment the loop variable x by 2 after each loop. So for the case of 11, e.g. 11, if we're checking n equals 11, we would check out the numbers 3, 5, 7, and 9. Then we don't care about 11. That would not be that'd be greater than n minus 1, right? 11. So we just check those numbers out. 11 is not divisible by any of those during each of those 4 loops, so we would never return false there. This would never evaluate to true. So we get past the loop and we return true, which is expected for 11. So that's our algorithm. That's our cooking recipe. We can then put that code that up in any coding language. Enjoy. It's a fun one. isPrime, it really is.